So the quantum journey continues. So in the videos thus far, I've kind of sketched out quantum physics a little bit. I talked a little bit about Planck's equation, E equals h nu. And then in the previous video, I talked a little bit about the ultraviolet catastrophe. It strikes me that if I'm going to really do this from scratch, then I shouldn't assume that you know what frequency, nu, looks like a V. I can't assume that you know what that means. And so I wanted to take this week and back up a little and talk a little bit about frequency, wavelength, amplitude, wave kinds of stuff, because you're going to need to know a little bit about that before we get very much farther. So let the games begin with this video, which is on frequency and wavelength and such. So I'm sure you're acquainted with the concept of a wave. Let me go ahead and bring this down here. So a wave basically, goes up and down and up and down and up and down. That's not the best drawing, but you get the basic concept of what a wave is, right? So there's some features of this. Let me go ahead and draw a baseline through this. We'll call it the arrow of time. Time marches on. So let me go ahead and draw a T for time. And so the height of a wave is known as the amplitude. So I'm going to just put a big old A there for the amplitude. And so amplitude basically means the height of the wave. It's not both of these. It's because this is positive, negative. There's positive amplitude. This is negative amplitude. So amplitude is one feature of waves that you should be somewhat acquainted with. Another aspect is if you go from one point, let's call it this point right here, to the equivalent point on the next wave, we could have done it from here to here. We could have done it from here to here, because even though I've not drawn it well, you get the basic point. It's a cycle. It keeps cycling. And so this distance from one point to the equivalent next point is called the wavelength. And it's usually symbolized by the Greek letter lambda in the literature. So that's another concept that you should know when it comes to waves. The wavelength is the length from one point on a wave to the equivalent point on the next wave. So that's wavelength. The final concept you should know about is the concept of frequency. It can be, I have seen it written with an F. It's my attempt at a nice, stylish F. It's also often written with a Greek nu, which unfortunately looks like a English V. I've tried to write it a little different, but that's nu, and it's the word for frequency. And what is frequency? Frequency is the number of cycles per second, the number of cycles per second. And so if time is marching on, then let's say that there is 1 second from here to here. Let's say that there's 1 second between these 2 points. How many cycles has it done? 1 cycle, 2 cycles. So that's 2 cycles per second, which you may have also heard of of a hertz. How many hertz is something? A hertz, named after a guy named Hertz and abbreviated like that, a hertz is a cycle per second. So this would be 2 hertz, 2 cycles per second. That's really all there is to it. If it's too abstract, picture a wave. I'm standing on the beach and I'm watching them go. Okay, what's the amplitude of that wave? Well, it's about a foot. That's a wave. That's a little wave. What's the wavelength? Well, what's the distance between the waves that are coming in? There's a wave. There's a wave. What was the distance? That the next one was when the first one came in. And then how many waves are coming in a second? How many cycles per second? That's frequency. Now I'm dragging it out. That's pretty much all there is. But you do need to know about frequency and about wavelength and amplitude in order to explore light and eventually quantum mechanics. Here is Planck's famous equation again. Energy equals Planck's constant, which you'll remember is h, and then times the frequency, which is nu. And that's Planck's famous equation. Well, let's not stretch it out any further, shall we? This has been a video on wavelength, frequency, amplitude, and in general, some basics of waves.